Hi folks, it's Mary Clark, and today we are going to talk about PCRs and how to get your labs up and running for our PCR labs with your mini8 machine. All right, so first, let's talk about why do scientists do PCR in the first place? So PCR is a way for us to copy DNA. So why do we need to copy DNA? The DNA samples that we isolate in a lab or at a crime scene, your typical forensic samples, those samples aren't ready for us to analyze. In all the labs that we are doing, we need to focus on a specific piece of DNA. So in many cases, that's going to be a gene. So one analogy is a book. Like, let's say your whole genome, all of your DNA is like this big book, right? But for the labs that we're doing, we only need maybe this passage right here on page 42 for our lab. But maybe another group is interested in a passage on page 385. So we need to be able to focus our attention just on the specific piece of DNA that we need. And we use an ingredient called primers to be able to do this. The other thing that PCR does is make many millions and billions of copies of that piece of DNA. In this way, PCR is kind of like a molecular copy machine. And then we're actually able to take the product of those PCR reactions and analyze it in our lab. What we will be doing is using it in a gel electrophoresis. All right. So we need a way to do PCR at home, and we have the equipment to do that. And what I'm going to show you right now is how to use that mini PCR with the devices that you have at home. So on your Baxter Box at Home central document, we are going to go down to the part that says download our mini PCR app. And this is going to be for our week 3 meeting. And this is going to bring us to the mini PCR download center. So if you scroll down, there are lots of different devices that this is supported on. What you need to make sure is whatever, whatever you are looking at, you need to make sure that that device has a USB port. So I'm on a Windows device right now, so I'm going to download this one. So that's going to be going for a little bit. All right. So as that is going, let's talk about the 3 labs that we're going to be doing this week. You're going to be, for the folks who are doing PCR, we're going to be doing crime scene investigation, which is the simplest one to do. Anytime you begin PCR, this is the lab that I do first in my biotech class. And then we have 2 others, which are PTC taster lab and then the GMO lab. The crime scene investigation lab is from BioRad. And remember, all of the gels that we're running are going to be run on the blue gel system. So just a heads up, the directions for the crime scene investigation lab have you running your gels on a traditional system, but we are going to use this blue gel system. The PTC and the GMO labs both are from mini PCR. And so those directions have embedded in the directions the way to use your blue gels for that. Each of these labs have a slightly different gel that you need to make. So when you're ready to make your gels, I know the crime scene investigation lab takes a 3% gel, the PTC lab takes a 2% gel, and I don't remember off the top of my head what the GMO lab is. All right, so I am done with my download. So I'm going to, just on my screen, I'm going to set this up. So there's a little setup wizard that's going, and I'm just going to choose next, download it to my computer, and install it. All right. So that is going, which is great. Once it's downloaded and installed, I'll be able to show you what we're going to be doing to actually run these programs. Okay. So for a PCR reaction to happen, there are going to be 3 steps. What you need first is the DNA strands that are attached to each other, you need them to separate out. So there's a very, very high temperature step. The first step is called denaturation, where you're separating the double helix of the DNA. The next step is called annealing. So remember I mentioned the primers? The primers are going to come in and just attach to that little bit of DNA that you want to study. And then the third step is extension, where the primers set the tone, and then your polymerase is going to be able to read the original strand of DNA and make your copies. All right. So my wizard is done. Let's see if this downloaded, and it automatically popped up on my computer, and I'm going to share my screen again. All right. All right, so let's look at our mini PCR machine. All right, so you'll notice that nothing's running right now, which is fine. There are no programs in here at all, so we're gonna have to make one. What I'm gonna show you is the program for the crime scene investigation lab. I'm gonna click this plus button, and let's see if this works. It's being a little bit funny. There are no protocols in the library, that's fine. All right, so now we have it. I'm gonna go PCR right here. I'm gonna title this protocol CSI for our crime scene investigation PCR. Our initial denaturation is going to be 94 for 2 minutes, which is 120 seconds, that's good. The next one is gonna be 94 for 30 seconds, that's good. The next one is gonna be 52 degrees for 30 seconds. The next one for our extension is going to be 72 for 60 seconds or 1 minute. And our final extension is going to be 72 degrees for 10 minutes. So that is going to be, we need 600 seconds for that one. All right. Number of cycles, we're going to repeat the denaturation, annealing, and extension for 35 times, I believe. All right, I'm going to save this. Great, so now we have that in our protocol, or in our library. Anytime you need to make another new protocol, you're gonna push that plus button. The other options right here, heat block, we're gonna use heat block for the PTC lab and the GMO lab. A linear ramp might be helpful in, like, let's say we were doing cellular respiration with the algae beads. Let's say you wanted to go from a low temperature to a high temperature and see how that affected the beads. You could do a linear ramp for that. You can set your initial temperature, you can set your final temperature and figure out how long you want it to go from beginning to end. And then flex is what it sounds like. It's flexible for a variety of those purposes. Okay, so now I am going to connect my device. So I have my mini PCR machine. I am going to plug this in. And the lights on the side, if I turn it on, the lights on the side should go on, which they are. And I'll show you guys that. So the lights are flashing up on that one. Just so you know, I have a mini 16 that was in my classroom when I went to go get it, but you guys all have mini 8s. And then we have our USB cord to hardwire it in. The nice thing about the mini 16s that I have is I could control it on my phone because it has Bluetooth capabilities. The mini 8s, you need a hardwired connection for. All right, so as I get this cord in order, let's talk about the ways that we're going to use this. All right, so I have my USB, and then I'm gonna hook it up to my USB on my machine. All right, great. So now I'm gonna share my screen again. Okay. Now, there was a pop-up, yes. So once I plugged it in the USB port, I didn't have to do anything on my computer. It just automatically popped up. So this is mini16m.Jackson. So on the side of my mini8, it says the name that I see up there. If you decide to get some of these machines for your classroom, you can actually edit the name right here. And then you can edit this Mini Jackson name right there, which I'm not going to do right now. All right, so we have the device, great. So now let's go to running. Oh, so something's running right now, so I am going to stop that. Let's see. Stopped. I'm going to figure out what's going on. I definitely don't want that running right now. Okay, let's go to our library. Let's go to CSI. Okay, so let's go back to our device. I am going to double click this. Now running, stopped, Jackson. All right. And there's something funny going on with this. Let's see if I can get out of here. Oh, and actually, I think I know what's happening. Something in, I bet it's running from my phone. All right, so I'm going to go to my phone and I am going to stop this from working. All right, so now actually, this is kind of interesting. You can see this device, we have the heat graph going, so you can see the temperature and what it's at in this machine right now. So now I see that hopefully I will be able to pause this. All right, so I've paused that, which is good. And as this is running, it actually sometimes gives off like puffs of air and you can like hear it running, hear the fans going in this. So that's all good news that I know that it's actually going. But now, let's see, so that is done. I want to X out of here. Let's go to my library again. Go to CSI, and let's say I want to run this. So for my actual experiment, what I'm going to do right now is just turn this off. All right, so I'm going to open this for my experiment. Let's say I have done all of the pipetting that I need to do. I am going to put in my PCR tubes. I'm just going to pretend right now that these are going in the machine. All right, so those are in my PCR machine now. I'm going to put on the lid, and now I'm going to run that program. So I'm going to go CSI, and I'm going to hit run. And it's not going because I didn't turn on the machine. All right. So I want to run the CSI program. And I'm still having trouble stopping this. Hopefully you guys won't have the same trouble that I am. But I'm going to figure out how to do this, and then we can talk about it in our Monday meetings or in our office hours. All right, so that's the basics for getting our mini-8s to work. Again, a lot of times it just takes troubleshooting. You guys saw me troubleshoot during this. And please reach out with emails or on Slack or ask questions during the Monday meeting or during the office hours if you have if you run into any problems. All right.